I'm Mwakyusa Lupakisyo from Sokoine University of Agriculture in Tanzania. I'm from the Department of Crop Science and Horticulture under the supervision of Dr. Newton Kilasi. Today I'm going to present to you a topic called characterization of selected rice dresses, tolerance to flooding in Tanzania. And to my right hand side, these are the pictures to appreciate what I'm going to do.
Rice is one of the well-known important staple food crop for more than half of the world population, and it is ranked as the third important food crop in Tanzania after maize and cassava, and almost of 20% of farmers involved in production of rice in Tanzania. And this is a picture to show how rice is being a value crop in Tanzania, and this is the demo plots at Sokoine University of Agriculture. The total land area used under rice cultivation in the country is 1.1 million hectares, and the crop is being adapted to rainfed lowland, irrigated, and upland with 71, 9, and 20% respectively. And rice is the important staple food second to maize with 8% national caloric intake in Tanzania. And this is a value chain. As we see, a lot of people have been employed in this category of crop. And the crop serves as a source of employment, income, and food security for millions in the rural areas. And the yield of rice in Tanzania ranges from 1 to 3 tons per hectare, while by comparing with the African yield standard, it is 2.5 tons per hectare, and that of Asia is 4.4 tons per hectare. And this is picture that shows how people are involving in the crop, and it's really employing a lot of people, and most of people are depending for income in this crop. Let's come to the production constraints that are being imposed by flooding. And by introduction, flooding is the major threat in rice husbandry for most of the low-lying, non-irrigated zones, and the stress is being attributed by the global climatic change as well as human activities, and the stress limit germination and early seedling growth. The interference results in severe crop losses, which then threaten rice production. And this, as we see, this is a flooding, which attacks the crop at any stage. And wherever there is a climate changes, then it may come without any expectation and it kills a lot of crop. Then we get crop losses. And the stress is being restricting gaseous exchange, which then hampers the biochemical processes, and these processes include respiration and photosynthesis. And the alteration of these processes it is known to be very destructive to sensitive varieties compared to the tolerant ones. And the poor crop establishment and or no germination has been experienced in direct seeded rice areas, which are invaded by floods soon after seeding. And this was one of the experiments, as we see. After submergence, only these patches that have been raised are the tolerant one, while others have been killed by submergence. Flooding disturbs the land, interferes with plant growth, and finally high crop losses. And in Tanzania, about 71 of the 1.1 million hectare for rice cultivation is prone to flooding, and the major rice growing area are experiencing severe losses, and one of them is Kilombero floodplain, with farmers are getting less than 2 tons per hectare. And rice production is the major activity at that area, and the majority are depending on it for their income. Crop losses result into lack of food, but also interfere their business, which increase poverty. The current situation: there is no any reported cultivar in Tanzania that is tolerant to flooding over the two stresses. Most of farmers are using their landdress cultivars for rice production due to their preferred traits and purchasing power. And farmers using susceptible cultivars are experiencing total crop losses, therefore faces food insecurity and economic crisis, which necessitates the importation of more food. And this is one of the well-known landless It is known as Lupakisyo, is the most valuable one with a high price compared to any other rice cultivar in Tanzania. So it has been preferred because of their taste and aroma. So most of the people or natives, they like practicing or using those landlasses due to their preferred traits. And the identification of the tolerant landless is inevitable to alleviate the problem. For this case, the adoption will increase germination, survival, and crop standing. Furthermore, the introduction of tolerant varieties will be a long-term solution towards the stress. This will help to alleviate food scarcity and therefore strengthening the economy of the crop-reliant people. This was one of the experiments done by Ismail. As we see, this is Cayenne, is a tolerant rice cultivar and anaerobic germination, while this one are very susceptible under anaerobic germination. Therefore, characterization will enable to come up with a cultivar that is tolerant under such stresses. Way forward. 200 up to now landless cultivars have been collected from rice growing areas in Tanzania, and some of them are sensitive and tolerant checks that have been imported from ill. These landresses will be assessed based on the two flooding stresses. One is anaerobic germination in direct seed system and complete submergence at the vegetative stage. And this was the experiment on the anaerobic germination in those areas which are direct seeded with rice. So in direct seeding areas which receive early rainfall, then fertilization can be the helpful process to come up with the tolerant. For easy screening and saving time, the planting material will be first screened in the screenhouse. Then the initial seeds of the identified tolerant landresses will be taken for field experiment in the flood-prone areas. Same landresses will be used for the two stresses, and the protocol that will be used will be that developed by International Research Rice Institute. And this was a experiment for complete submergence at vegetative stage to come up with the tolerant cultivar, and first you have to establish the seedling for about 14 to 21 days before submerging. Identification of the tolerant genotypes will take 2 phases per each stress. This will include morphological and molecular characterization. And the morphological characterization aim is to look how these materials perform under such stress. Then the data that will be collected will be used for evaluation. The morphological measurement to be taken for anaerobic germination will include the percent survival 21 days after flooding at 10 cm water depth, colectile elongation, growth parameters, and yield components. And these parameters will be compared among the cultivars tolerant to this stress. But also measurement for vegetative stage complete submergence at 100 cm water depth will be the percent survival, shoot elongation, growth parameters, yield components. But also the field identified tolerant landresses, their DNAs will be extracted. And this was another experiment for the submergence tolerant. This is 21 days. So after the submergence, as we see, the only tolerant cultivar will be recovering after 21 days. So, and those that will recover, we regard them as the tolerant. The identification of the known genes using specific primers will be done after the extraction of that DNA, and the mapped gene, that is sub1, for complete submergence, while AG1 and AG2 genes are for anaerobic germination, and only those genotypes that will have those genes will be regarded as tolerant and recommended for cultivation, but also will allow for further breeding processes, just like introgression into the higher yielding susceptible cultivars. And this is another experiment. As we see, some of the cultivar have been elongated So they have gone severe the post-recovery and they can't recover, while others that have the sub-1 gene that offer resistance for the vegetative submergence tolerance, as we see, they have undergone quiescence strategy by reducing their metabolic rate, so they cannot die, and this we need them for production under such environment. Expected outcome for vegetative submergence. Under vegetative submergence, there is a gene called sub1 that is a major QTL that offer tolerant towards the stress, and it accounts to about 70% of the total phenotypic variation. Therefore, identified tolerant genotypes will be able to survive up to that percent, and this will result to increased yield once compared to the use of successful cultivars. And this was one of the experiment also, as we see all those places that have well covered with rice are the tolerant one with the sub1, while those poor. And by comparison between those that have sub1 and those non-sub1, the non-sub1 are very susceptible. Under submergence, there is increased reactive oxygen species metabolism, which then tend to decrease in antioxidants, also decrease in the growth parameters, which then they weaken the metabolism, and the weakening of the metabolism results into the death. While the mechanism for the tolerant one, as we see, it undergo the quiescence strategy, that is to minimize the metabolic rate under such stress, then increasing the survival rate. The expected outcome for anaerobic elimination under such stress, two major QTL have been identified, that is AG1 and AG2. In combination, they offer up to 65% phenotypic variation and increased germination percent, and this is due to the strategy called colectile elongation, that is a escape strategy, and this will result to increased germination, crop stand, and final yield due to the increased plant population that survives. And this is another experiment, as we see, that was done under anaerobic elimination, and only the survived rice is considered to be tolerant, and we are going to confirm if those having those QTL are the major that are performing better. Access of the characterized planting materials. These landraces cultivars are found to farmers and are sold among themselves. The price is low compared to the improved that are in the formal system. And for example, when compared between the landrace and the improved one, 1 kg of the landrace may cost up to 400 Tanzania shillings per kg, while for the improved one may cost up to 2,500 T shillings per kg. And the majority of the small-scale farmers have the capacity of accessing these materials. The experiment will be done to flood-prone areas where the farmers cultivate their rice. Farmers will be able to see the progress of the experiment and which genotype perform well. Therefore, this will ease adoption to tolerant landraces for cultivation has increased yield. But finally, this will increase household income and national income will increase also, while will reduce the poverty among the natives. Youth involvement. Youths are the money power for most of the rice growing areas in Tanzania, and they are involved in production and various field activities. It is a big group in Tanzania that have access to smartphones. This will enable them to take pictures and share them into different social networks. Therefore, information will be disseminated all over the rice growing zones. The adoption to the characterized tolerant cultivars will increase, and finally yield will increase. Increase in the yield will reduce the food scarcity and the cost of rice importation. And these are the references, as you see. And for that case, thank you for listening.